The world is a chaotic place. From Heisenberg's uncertainty principle to the butterfly effect, our lives are fraught with randomness. Python understands this and comes equipped with a random module which gives you a wide variety of functions for generating random numbers. This is useful if you want to add unpredictability to your games or if you want to run Monte Carlo simulations. But the games begin. We begin with a serious warning. Random numbers are used in cryptography, but the functions in the random module were not built for such purposes. In fact, Python explicitly warns you against doing so. But for most other applications, the random module is a fantastic tool. To use the random module, you must first import it. To see the methods available, print the directory for this module. Today we will explore many of these functions and give a wide variety of examples. We will begin with the random function. This function returns a random number in the interval 0 to 1. The square bracket means it can return 0, while the open parentheses means it will never return 1. Let's see some examples. Let's display 10 random numbers from the interval 0 to 1. Begin by importing the random module. Next, use the range function to perform a loop with 10 iterations. In each loop, print a random number. Run. Those numbers do indeed look random. What if we run this again? 10 very different numbers. When you run this, you should get 10 different numbers than the ones displayed here. That's exactly what you want from the random function. Another feature of the random function is that it represents the uniform distribution. Without getting too technical, this just means the probabilities of numbers being chosen are equally spread out over the interval. What if you want to generate a random number from a different interval? For example, how would you generate random numbers from the interval 3 to 7? There are several ways. For starters, you could write your own function. To do so, start by picking a random number in the interval 0 to 1 by using the random function. Next, multiply by 4, so the random number is in the interval 0 to 4. We multiply by 4 because that's the width of the interval 3 to 7. Finally, add 3 to shift the number to the target interval 3 to 7. Let's write the function to do this. Import random. Write the function by picking a random number, then scaling and shifting. Let's print 10 random numbers using this function. As you can see, they all lie in the interval 3 to 7. But there's an easier way to generate random numbers from any interval. Use the uniform function. This function is included in the random module. So why did I bother writing a function that Python already gives you? The reason is to highlight an important fact. The random function can be used to build customized random number generators. In fact, it's the key ingredient for many of the functions in the random module. Let's test the uniform function. Like before, we will pick 10 random numbers uniformly chosen between 3 and 7. Run. Excellent. The random and uniform functions are both uniform distributions. But there are other distributions where some groups of numbers are more likely to be chosen than others. The most widely encountered is the normal distribution, also known as the bell curve. A normal distribution is completely described by just two numbers, the mean and the standard deviation. The mean is the average. It's where the bell curve peaks. The standard deviation describes how wide or narrow the curve is. You use the Greek letter mu for the mean and the lowercase sigma for the standard deviation. To generate random numbers from a normal distribution, you use the normal variate function. When you call this function, you must pass in both the mean and the standard deviation. For example, to generate 20 numbers from a bell curve with mean 0 and standard deviation 1, you call the normal variate function and pass in the two parameters. Notice how the numbers are bunched around the mean 0. Here are 20 numbers from a normal distribution with mean 0 and standard deviation 9. Notice that these numbers are more widely spread out. If you make the standard deviation small, the random numbers will be tightly grouped. If you change the mean to 5, you'll see that the random numbers are now bunched around 5. Sometimes you don't want a random number chosen from an infinite number of possibilities. For example, what if you want to simulate the roll of a 6-sided die? For this, you use the randint function. This is an abbreviation for random integer. If you want a random whole number between 1 and 6, call randint with the smallest possible integer, and then the largest possible integer. Now we're rolling. There are even times when you want a random selection from a list of values which are not numbers. For example, suppose you are writing a program to play rock, paper, and scissors. In this game, there are 3 possible outcomes: rock, paper, and scissors. To pick a random value from this list, use the choice function. When you call the choice function, pass in a list of values you want Python to choose from. I still think that rock should beat paper. In the random module, there is also a function called Socratica. This function gives the probability someone will like our video or subscribe to our channel. With your help, we can improve these odds. For your convenience, YouTube provides a subscribe button somewhere around here. And if you would like to help accelerate our production of videos, you can support us on Patreon or contribute using Bitcoin. Thank you.